Welcome you all. In this video we will see how we can generate and visualize a sinusoidal signal in both continuous time and discrete time. So as you see here, sinusoidal signal can be mathematically written as x of t equal to sine 2 pi f times of t in a continuous time, and in a discrete time it can be mathematically written as sine 2 pi f times of n, where f is the frequency of a signal in hertz. Right, now let's see how we can build this in a MATLAB. So let's create a new script. As we do always, first we have to create a x-axis variable, that is time for a continuous time, and samples n for a discrete time. So just save this file first. Sinusoidal signal. Right, so let's first create a x-axis variable. So I just take from my previous program, okay, and just I rename this figure as sinusoidal signal. Right, okay, so now let's see how we can make a plot of sinusoidal waveform in a continuous time. So we already declared the time variable lies between -10 to 10, right, and we know the sinusoidal signal mathematically written as 2 pi sine 2 pi f times of t, right. So t we already created. Now we have to declare the frequency f. So let's take that frequency f as, let's say, f equal to 1 hertz for an example, right. So now I am going to create a amplitude. So amplitude, let's take this y1, which is equal to sine in bracket 2 into pi, which is a 3.14 into f into t. So this is going to find the amplitude for each of the time step t, right. Alright, so now we created a time as well as corresponding amplitude. Now we go for making a plot. So let's create a plot function. First x-axis data followed by y-axis data. So this is going to make a plot of a sinusoidal waveform in a continuous time. So now I just label the x-axis and y-axis, and also I'm going to name the plot. That is, I'm going to keep a title of the plot as a sinusoidal signal in a continuous time. So x label time, y label amplitude, and title let's keep sinusoidal signal in a continuous time, right. Okay, so now the same we try to do it in a discrete time. So first I declare the subplot. So I want to keep sinusoidal signal in a discrete time in the second position, right. So I keep number 2. Then I should create now magnitude, right, for each of the n values. So let's have a magnitude as y2, which is equal to sine open bracket 2 into pi, which is a 3.14 into frequency into n, right. N is actually a discrete time values in x-axis, right. So now we made a amplitude also, so we'll call for a plot now. So for making a discrete plot, so we'll be using a command called stem. Let's keep x-axis data is n, and the magnitude is y2, whereas amplitude is y2, right. So now we label the data for both x-axis and y-axis, and also we keep a title of the plot. So x label is actually a sample, and y label is amplitude, and the title is actually sinusoidal signal in a discrete time, right? Okay, so now you just run this program, and as you can see here, we have a sinusoidal signal in a continuous time. Similarly, we have a sinusoidal signal in a discrete time. And since we kept the frequency as 1, so we actually able to see only part of the sinusoidal waveform. So what we can do is we can reduce the frequency further, so that we can visualize the sinusoidal signal properly in the discrete time also, right? So let's change this frequency from 1 to 0.1, let's say. Save this and run. Now you can see, right? You can see that this is a sinusoidal signal in a continuous time, and you see here this is a sinusoidal signal in a discrete time. Thank you.